So I just want to go through another example of undetermined coefficients, and I also want to just go ahead and show you some stuff using Maple. Again, you do not have to use this. It's a tool that's available to you on campus. All right. Some of you I know have some familiarity with it, but I don't require you to use it. I'm just using this to illustrate that you can save a lot of time when doing some of the more complicated problems in your book, because keeping track of everything by hand is a hassle. And you're not cheating. I know some of you think this is some kind of bad thing to do. Remember, as technology improves, we have better tools available so we can solve more complex problems. Should you memorize formulas for basic derivatives and things? Yes, because when you're doing things by hand that are simpler, it's faster to just do it by hand than to get out the computer and start typing everything in. Or if you're taking a standardized test, you may not have Maple or something like this available to you, so you'll have to know those things. I've even had, for example, a friend of mine applying for a job as a computer programmer, but he has a math degree, and his employer during the interview asked him to differentiate some function because he wanted to make sure that the person actually knew some math and wasn't just saying, I have a math degree, because the reality of our world is you can get grades in classes and not learn anything. That's the reality. All right. So knowing these things is useful, but knowing how to use tools is also useful. So we're going to consider this equation we have here at the top. So we have a second order equation and two initial conditions. So this is an initial value problem. Now in Maple, I like to do things by typing, not by pointing and clicking. I type faster than pointing and clicking, so I use the kind of typing math input for this to do the math. The rest of this is just inserted text that I put in. So everything in black. So again, let's just go through the process. We'll find the roots of our characteristic equation. So our characteristic equation is just x squared plus 10x plus 7. We're going to solve that equal to 0. All right. I've already run through this, but once you enter this term, it's going to give you these answers. And we can see that there's two roots. They're real, but they're not very pretty. That's another reason why using something like Maple is useful, because it'll use these non-pretty numbers and do all the simplification for you. So we've got two real roots from the quadratic formula. That's all this is using. And so what we have to do is define our solution to the homogeneous problem, YH. So I'm just calling it YH. And when you define anything, function or number, you just use a colon followed by equals. And that tells the Maple to use this label, YH, to represent what's coming next. And what's coming next is a function. So to do functions, we take our variable x, and then we put a little arrow, which we can just do with a hyphen and a caret, right caret. And then we type in our function as if we were typing in a calculator. And that's all I've done here. The only thing here is I'm introducing constants that are unknown to us, C1 and C2. In Maple, to get subscripts, you just type the letter you want to use, and then you use square bracket, and then the number 1 or 2 or 3 or 4 or whatever you want to use. So I've typed all this in, and when you've entered it, Maple will spit out the definition in more mathy notation, and then you can kind of look at it to see, did I type it correctly? And it's like, yes, that's the form we want. So that's our solution to the homogeneous part of the problem, general solution. We don't know what C1 and C2 are. And we look at our right side again. We've got a sine 4x, and we've got a plus an x times e to the x. Using our method of undetermined coefficients, we can't group these two terms together as a single term that fits one of the basic forms that we've talked about. So we have to treat each of these separately. And this is where linearity comes in. We can just add two different guesses for each term and then add them together to find our yp. So for the sine term, like any trig function like sine or cosine, we're going to add some constant a times sine of 4x plus some constant b times cosine of 4x. If you like to add the cosine first, that's fine. If you want to use letters w and z, use whatever letters you want. That doesn't matter. All right. The point is we have to introduce enough different constants to cover our bases. So this is the general solution of yp that covers the first term of our right-hand side, the sine of 4x. For the x e to the x, that's a linear function, a first-degree polynomial times e to the x. So I introduce a first-degree polynomial. I'm going to use capital C's now. Notice I'm using capital C's for these instead of lowercase c's that are used for the other ones. So Maple knows that these are different. And then I multiply this by e to the x, which in Maple we just type exp for exponential of x. And when you enter that, it would just show you in math notation that you've done it correctly, and you can see that yes, that's the form we want. This is the human part of the problem. You are coming up with this from understanding this method. What we have to do next? Well, let's just double check. Basically what we have to do is we have to figure out these system of equations to determine these constants a, b, c sub 0, and c sub 1. So basically we're going to plug in our yp into our linear differential operator, and we're going to go ahead and subtract the right-hand side at the same time, because then what we see we know has to be equal to 0. All right, so what am I doing here? I'm using a simplify function, which is going to group some like terms together, but it won't do it perfectly because we have parameters. But what I'm doing is I'm differentiating yp of x. This is how I say do two derivatives in x. And then I'm adding to that 10 times the derivative of x. I don't have to put, for first derivative, I just put right like this. And then I add to that 7 times my yp of x. And now I'm subtracting the two terms from phi of x, because I want to set all this equal to 0. So when we hit enter on that, we get this expression that we have down here. And notice that we have different terms. We have a sine term, there's a cosine 4x term, a term that's only an e to the x term. Oh, let me get my highlighter to work better. Oh, computer's freezing here. We have a, oh geez, sorry. E to the x term. And then we have, look, the next one is also an e to the x term. They weren't combined because Maple saw two different parameters and it's thinking of those as different things. And then we have another one, but this one has an x. This is an x e to the x term. And then we have another cosine term with this 40a in front, and we have another sine term over here, and another sine term here, another x e to the x term here. So there's 4 types of terms that haven't been grouped all together. There's a sine 4x term, a cosine 4x term, an e to the x term, and an x times e to the x term. And those are the 4 different terms, and that's why we had 4 constants, a, b, c0, and c1, because we need 4 equations and 4 unknowns. So we have to set all this equal to 0, which means we have to do some grouping on our own. So I'm just saying solve. System of equations, so I put all the equations in brackets. I separate them by commas. And when I'm done with my equations, I just close the brackets, and then I use a comma to then make my list of what my variables I'm solving for are. And just look at cosine. There was a negative 9b times the cosine. And then there's also over here this 40a cosine. So that's why I put negative 9b plus 40a equals 0, because I know everything up here has to be equal to 0. So the cosine term has to be 0, because I've already subtracted the right-hand side of the equation. That's already been included. And then I go to the sine term. I do the same thing. I notice there's a 9a, a negative 9a, and a negative 40b, and a negative 1 times the sine of 4x. So all those together have to be 0. Now, we're doing this in class. We kept the phi of x on the right-hand side. That just amounts to moving this minus 1 to the other side and having the plus 1, because there was a sine 4x term in phi of x. But this is the same equation. Then I do the e to the x term. I notice there's 12 times c1 plus 18c0 times e to the x. Our phi of x doesn't have that, but anyways, we've set it up so these are all set equal to 0. So that's equal to 0. And then I go to my x e to the x term. And I only have two of those. There's an 18 times c1 x e to the x, and there's a minus 1 times x e to the x, and that's equal to 0. So then I hit solve, and it tells me what all these things are. But it didn't tell me, it didn't set them equal to them. It didn't put those values into the labels A, B, C0, and C1. There's a quicker way of doing that. I'm not doing this the most efficient way. I'm doing this to illustrate steps. So once we have this, then I would just type down and copy. I'm going to define A to be that number that I see up here. And then I have to use a semicolon to separate commands in Maple. When you finish a command, a math command, semicolon is what ends that. And then I define B to be the number I see, and then I define C0 to be the number I see, and I define C1 to be the number I see. And now once I hit enter on this, now these symbols that we introduced are assigned those values. So when I type in what is my yp of x and hit enter, it actually types it out with the numbers put in place. And again, we see it's of the right form, and now it just has the numbers put in. So next thing, what do I do? I just want to check. I want to define my general solution. Remember, that's a function. So define it as a function from x mapping to yp of x plus yh of x. And I'm going to define it, and then I'm going to have Maple type it out so we can see it. And that's what these next two lines are. The first line is just Maple saying that you've defined this. And the next line is actually telling us this is what y of x is. It's all this stuff. And you can see how it grouped it. It grouped it not how we do it, but it gave us yp. I typed it as yp of x plus yh, so it put yh second. It doesn't matter. But you can see the little c1 and c2 are still over here. We haven't determined those yet. This is our general solution. So now we have to identify these constants by using the initial conditions. Before I do that, I want to just check and make sure that everything's working okay. So all I'm doing now is I'm taking my general solution y and I'm plugging it in to my L of y, and then I'm subtracting off the two terms from phi of x. And if I did everything's done correctly, this is our general solution, so this should be 0. And when I hit enter, yes, it's showing me that it's 0, which is just confirming to me that Maple has stored the correct function that I want to use. It is a general solution. Remember, the C1 and C2 for the lowercase c1 and c2 could be anything, and this would still give me 0. We haven't assigned those values yet. We have to find those values so that they solve the initial conditions. So again, we're solving a system of equations. So the first equation is y of 0 equals 1. That's our first initial condition. For the next initial condition, it's a little technical. I have to evaluate the derivative of y at the value x equals 0, and then set that equal to 2. And Maple's going to do all this, and it's going to keep track of all the numbers and everything, and it's going to keep track of these lowercase c1 and c2, and it's going to solve the system of equations for those two numbers, and we get these values here. And again, it's doing it symbolically, so everything's exact. There's no decimal approximations. It's going to use square root of 2 in this case to make it exact. Again, we just have to assign and type in the values to actually assign those numbers to C1 and C2, and then Maple spits them out, and we can just look at them again and say, does this match what was up there? Yes. Does C2 match what was up there? Yes. And now I actually have y of x, which I have here, and I just typed y of x, semicolon, hit enter, and it spits out the entire crazy expression for this problem. That's what y of x is. But again, I need to verify that we've done this correctly. I like to verify because I'd like to know that I'm done. So I'm just plugging in again our function into our differential equation just to make sure everything's good still. And then I'm asking Maple to compute y of 0. And then I'm asking Maple to compute y prime of 0. And when I hit enter, it spits out these three things. It spit out, that's the phi of x that I should have gotten. I didn't subtract it this time. so I didn't get 0. I could have subtracted it up here and then gotten a 0 here and still got the confirmation. It then computed y of 0, which is 1, which is what we needed, and it computed y prime of 0, which is 2, which is what we needed. All right, so it's a useful tool, all right? But when you pay attention to the assignments, I'm asking you, if you want to use this, I don't mind, but you have to write your information in a way that illustrates that you don't understand the process. I don't need to see how you solve a system of equations. I need to see that you know what system of equations to solve. So just write down, oh, when I had to determine my undetermined coefficients, here's the system of equations that I'm solving. If you do that correctly, I can see that you did it correctly. If you do it incorrectly, I can see that you did it incorrectly, and I can guide you and tell you, hey, looks like you made a mistake when you're doing this step. Go back and check and see what you did wrong. But again, this is not a requirement, but it's a useful tool. So just view it that way, all right? If you are familiar with it, then, feel free. Check your work with it. It's great for checking algebra. Computers do algebra perfectly because algebra is a programmable process. Computing derivatives and antiderivatives of the basic functions is programmable because there are formulas for those. But again, if you are, for example, going to be taking the teacher certification exam, you're going to have to do problems without Maple. So you have to get good at knowing the formulas and being able to use them quickly because it's a time test. So that's the practicality of needing to know those things, is for test-taking purposes. All right. But when you're doing more complicated things, you can save some time by using the tools that are available to you. And if you want some help, because learning to use any new software is not easy always, especially technical software. You're going to run into some problems. You're going to mistype something, and you're going to get some error messages, and you're not going to understand what's going on. What I like to do is, when I'm trying to do a project, at the end, I always put this line, restart. What that does is, if something messes up and not working right, I just go to this line, I hit restart, and it just erased all the memory that I had done. And I'd have to start all from the beginning again. And I would just start from the beginning and make sure, okay, we'll do that again. And Maple's doing it. There it is. Okay, and then I just copied that down and I did this again. I have to re-enter all these lines. That's all. And notice it's putting it in a very small font. I made it bigger for this video. But I'm just going through and entering everything. I know it worked already, so it should work again. But you may run into an error, and sometimes just clearing all the memory is the easiest thing to do and start over. It doesn't take more than a minute or so to go through here and re-enter all these math code lines. Just checking that everything's still working. Because it's inevitable when you do any kind of programming, and this is basically like a programming that you're doing, you're going to mess up. And the thing is not to get so frustrated that you just don't use the tool. Because once you learn to use the tool and you start minimizing your mistakes with using it, then it is very useful and you'll love having it. So that's all. I just wanted to illustrate that and give you another example. And again, this was an example where the right-hand side had two terms that we couldn't group together, but we just treat each term as a separate basic case and then add those two guesses together to define our y sub p.